management. The syllabus which we are going to cover is characteristics, generation and collection of municipal solid waste as well as transportation of solid waste. The engineered systems which will be used for solid waste management, that is reuse, recycle, treatment, its disposal, etc. So what is solid waste? Due to rapid increase in the production and consumption processes, all the societies generate as well as reject some solid materials regularly for various sectors such as agricultural, commercial, domestic, industrial, and institutional. From all these societies, some waste is generated regularly. The considerable volume of waste is generated and rejected, and it is called as solid waste. In other words, solid waste are the waste arising from human and animal activities that are normally solid and are discarded as useless or unwanted. This waste is discarded as useless. So the solid waste management is the entire process which involved recycling process also. Solid waste management starts with the trucks picking up recyclable and delivering them to the recycling site. Solid waste management is associated with the control of waste generation, its storage, its collection, its transfer and transport, then its processing and disposal to achieve the best principle of public health. Next is the classification of solid waste. Solid wastes are the organic and inorganic waste materials such as product packaging, grass clipping, furniture, clothing, bottles, then kitchen refuse, paper, waste paper, appliances, batteries, etc. These are produced in a society which do not generally carry any value to the first user. Solid waste contains both a heterogeneous mass of waste from the urban community as well as a more homogeneous accumulation of agricultural, industrial, and mineral waste. While these wastes have little or no value in one setting, and the one who wants to dispose them, the discharge waste may gain sufficient value in another setting. Means after some treatment, these waste can gain some value after the treatment. So the knowledge of sources and types of solid waste as well as the information on composition and the rate at which waste are generated or disposed is very essential for the design purpose. And the operation of functional elements also, which is associated with management of solid waste. So according to the classification of solid waste, first classification is source based classification. It depends on the source of solid waste from which they are generated. So first is residential based classification. This refers to waste from apartments, dwellings, communities, houses, and consist of leftover food, vegetable peels, plastic, clothes, etc. So these are residential wastes. Second is commercial based classification. This refers to waste consisting of leftover food, glasses, metals, ashes, etc., which are generated from stores, restaurants, markets, hotels, motels, auto repair shops, some medical facilities, etc. And these are generated from various municipal activities like construction and demolition, street cleaning, landscaping, etc. These are the examples of commercial waste. Next is institutional waste. This is mainly consist of waste paper, waste plastic, glasses, etc. And these are generated from educational, administrative, and public buildings such as schools, colleges, offices, etc. Next source is municipal source. This includes dust, leafy matter, building debris, etc. Next source is industrial source. These mainly consist of process waste, demolition and construction waste, hazardous waste, etc. Due to industrial activities, the waste which are generated due to these activities are included in industrial solid waste. Next is agricultural solid waste. These mainly consist of spoiled food grains and vegetables, then agricultural remains, etc., which are generated from fields or farms. Next is open area solid waste. In this category, it includes waste from areas such as streets, parks, vacant lots, playgrounds, beaches, highways, recreational areas, etc. So these are the open area solid waste. Next classification is the type based classification. So the classification of waste which are based on types, that will be physical, chemical and biological characteristics of waste. So first is garbage. This includes animal and vegetable waste which resulting from the handling or sale or storage or preparation or cooking and serving of food. Garbage comprising these waste, and these waste contains organic matter which produces a very bad odor, and these garbage attracts rats and other vermins. Therefore, it requires special attention in storage, handling, and disposal of garbage. Next type based classification is ashes and residues. These are substances which are remaining from burning of wood, coal, charcoal, or coke and other combustible materials for cooking and heating in houses, institutions, or small industries, etc. When these ashes and residues are produced in large quantities, as in power generation plants and factories, these are classified as industrial waste. Ashes consist of fine powdery residue and clinker, which are often mixed with small pieces of metal and glass. Since ashes and residues are almost entirely inorganic, they are next classification is combustible and non-combustible wastes. These consist of waste generated from household, institutions, commercial activities, etc. And it excludes food waste and other highly harmful materials. Typically, while combustible material consists of paper, cardboard, which can be easily combusted, for example, textile, rubber, garden trimmings, etc. And non-combustible material consist of such items as glass, crockery, tin, aluminum can, ferrous, non-ferrous material, and dirt. Next type-based classification is bulky waste. Bulky waste means some heavy waste. These include large household appliances such as refrigerator, washing machine, which is not in working, then furniture, broken furniture, vehicle parts, some tires or wood or tree branches, etc. Since this household waste cannot be accommodated in normal storage containers, so they require a special collection mechanism. Next waste is street waste. Street waste refers to waste that are collected from street or parks or vacant plots, and they include waste paper, cardboard, plastic, dirt, leaves, etc., and other vegetable matters. So, in many countries, including India, there is an acute problem of the solid waste management system. Next type-based classification is biodegradable and non-biodegradable waste. So biodegradable waste mainly refers to substances which consist of organic matter such as leftover food, then vegetable, fruit peels, paper, textile, wood, etc., which are generated from various household and industrial activities. Because of the action of microorganisms, these wastes are degraded from complex to simpler compounds. The non-biodegradable waste consists of inorganic and recyclable materials such as plastic, glass, cans, metals, etc. So these are the example of biodegradable and non-biodegradable waste. Next, type-based classification is dead animals. With regard to municipal waste, dead animals are those that die naturally or they are accidentally killed on the road. Note that this category does not include carcasses and animal parts from slaughterhouse. Dead animals are divided into two groups, that is large and small, large animal or small animal. Among the large animals are horses, cows, goats, sheep, pigs, etc. These come under large animals, and among the small ones are dog, cats, rabbits, rats, etc. These are the small animals. The reason for this differentiation is that large animals require special equipment for lifting and handling when they are removed. If not collected properly, if we are not able to collect these large animals properly, dead animals pose a threat to public health. And since they attract flies and other vermins as they decay. Their presence in public places is particularly offensive from the aesthetic point of view as well. Next type-based classification is abandoned vehicles. This category includes automobiles, trucks and trailers that are abandoned on streets and other public places. However, abandoned vehicles have significant scrap value for their metal and their value to collectors is highly variable. Next type-based classification is construction and demolition waste. So these are wastes generated as a result of construction, repair and demolition of houses or commercial buildings or other structure. They consist mainly of earth, stones, concrete, brick, roofing and plumbing materials, heating system and electric wires and some parts of general municipal waste stream also. Next is farm waste. These waste results from diverse agricultural activities such as planting, harvesting, production of milk, rearing of animals for slaughter, and the operation of feedlots also. In many areas, the disposal of animal waste has become a critical problem, especially for feedlots, poultry farms, and dairies. Next type based waste is hazardous waste. Hazardous waste are those waste of industrial, institutional, or consumer origin that are dangerous to human being and the environment. This is due to their physical, chemical, and biological or radioactive property like ignitability, corrosivity, reactivity, and toxicity. These are some properties of this hazardous waste. Note that in some cases, the active agents may be liquid or gaseous hazardous waste. They may be in the form of liquid or in the form of gases. They are classified as solid waste as they are confined in solid containers. Typical example of these type of waste are empty containers of solvents, paints and pesticides which are frequently mixed with municipal waste and they become a part of urban waste stream. Certain hazardous waste may cause explosions in incinerators and fires at landfill sites. Others, such as pathological waste from hospital and radioactive waste, also require spatial handling. A proper, effective management should ensure that hazardous waste are stored properly, collected properly, then it is transported and disposed of separately after a suitable treatment to render them harmless. These hazardous waste should be disposed after a suitable treatment. It is compulsory. Next type based classification is sewage waste. So the solid byproducts of sewage treatment are classified as sewage waste. They are mostly organic and derived from the treatment of organic sludge, which is separated from both raw and treated sewage. The inorganic fraction of raw sewage, such as grit and eggshell, is separated at the preliminary stage of treatment. And these grit and eggshell must be buried without delay. The bulk of treated or dewatered sludge is useful as a soil conditioner, but it is uneconomical. Solid sludge enters the stream of municipal waste and special arrangements are made for its disposal. So these were the classification of solid waste. Next is the typical solid waste management system and their functional elements. Firstly, the solid waste is generated from household or industry or commercial places. Then this waste is stored and after storage this waste is collected. That is collection system. After collection of this waste, some of the waste is transferred and transported to directly disposal site and some of the portion may be sent to the processing unit, that is incinerator, or to prepare composting, and after that it will be disposed of. So solid waste management system contains a combination of various functional elements which are associated with the management of solid waste. The system, when put in place, facilitates the collection and disposal of solid waste in the community at minimum cost, while they preserve public health and ensure little or minimal adverse impact on the environment. So the functional elements that constitute the system are First is waste generation, then waste storage, then waste collection, then transfer and transport, then processing, after processing, recovery and recycling, and the last process is waste disposal. So, in waste generation, wastes are generated at the start of any process, and then at every stage, raw materials are converted into goods for consumption. For example, wastes are generated from household, commercial areas, industries, institutions, then street cleaning, and other municipal services. The most important aspect of this part of sewage solid waste management system is the identification of waste. This is the most important step to identify the type of waste. Second is waste storage. Storage is the key functional element because collection of waste never takes place at the source or at the time of their generation. The heterogeneous waste generated in residential areas must be removed within 8 days due to shortage of storage space and presence of biodegradable material. The on-site storage is of primary importance due to public health and economics involved. Some of the options for storage are plastic containers, conventional dustbins, used oil drums, large storage bins, etc. These large storage bins or oil drums can be used for institutional and commercial areas. Next process is waste collection. This includes gathering of waste and hauling them to the location where the collection vehicle is emptied, which may be transfer station, which is called as transfer station, that is intermediate station where waste from smaller vehicles are transferred to larger ones and also they are segregated in transfer station. And after this, they are sent to the processing plant or a disposal site. So the collection depends on the number of containers, frequency of collection, types of collection services, and the route which is decided. Next step is transfer and transport. This functional element involves the transfer of waste from smaller collection vehicles to larger ones at transfer station. The subsequent transport of the waste, usually over the long distance, to disposal site. The factors that contribute to the designing of transfer station, they include the type of transportation, transfer operation, then the capacity of solid waste generated, then equipment, then accessories and environmental requirement. Next process is processing of solid waste. Processing is required to alter the physical and chemical characteristics of waste for energy and resource recovery and recycling. The important processing techniques include compaction of solid waste, then thermal volume reduction, then manual separation of waste components, then incineration and composting. Next step of sewage waste management is recovery and recycling. This includes various techniques, equipments, and facilities which are used to improve both the efficiency of disposal system and recovery of usable material and energy. Recovery involves the separation of valuable resources from a mixed solid waste and delivered at transfer station or processing plants. It also involves size reduction and density separation by air classifier, magnetic devices for iron, and screens for glass. The last step of sewage waste management is waste disposal. Disposal is the ultimate fate of all solid waste. Their residential waste, semi-solid waste for municipal and industrial treatment plant, then incinerator residues, then compost or other substances that have no further use in the society. These type of waste will be disposed of. Hence, land use planning becomes a primary determinant in the selection, design, and operation of landfill operations. A modern sanitary landfill is a method of disposing solid waste without creating a nuisance and hazard to public health. Generally, engineering principles are followed to confine the waste to the smallest possible area. They reduce them to the lowest particle volume by compaction at the site and cover them after each day's operation to reduce exposure to vermin. Next is the factors affecting solid waste management system. So first factor which affect solid waste management system is quantity and characteristics of waste. The quantities of waste generated generally depends on the income level of the family. As higher income category tends to generate larger quantity of waste as compared to low income category. The quantity ranges from about 0.25 to about 2.3 kg per person per day. It indicates a strong correlation between waste production and per capita income. One of the measures of waste composition is density, which ranges from 150 kg per meter cube to 600 kg per meter cube. Proportion of paper and packaging material in the waste largely account for the differences. When this proportion is high, the density is low and vice versa. The waste of high density shows a relatively high proportion of organic matter and moisture and lower levels of recycling. The next factor which affects SWM system is climate and seasonal variations. There are regions in extreme north and south where temperatures are very low for much of the year. So in cold climates, drifting snow and frozen ground interfere with landfill operations, and therefore trenches must be dug in summer and cover material stockpiled for winter use. In tropical climates are subjected to sharp seasonal variation from wet to dry season, which cause significant changes in the moisture content of solid waste, varying from less than 50% in dry season to greater than 65% in wet months. The collection and disposal of waste in the wet months are often problematic. High temperatures and humidity cause solid waste to decompose more rapidly than they do in colder climates. The frequency of waste collection in high temperature and humid climate should be higher than in cold climates. In subtropical or desert climate, there is no significant variation in moisture content of waste due to low rainfall, and there is low production of leachate from sanitary landfilling. Next factor affecting is physical characteristics of an urban area. In urban areas, that is towns and cities, where the layout of streets and houses is such that the access by vehicle is possible and door to door collection of solid waste is the accepted norm, either by large compaction vehicle or by smaller vehicle. The picture is quite different in the inner and older city areas, where there are narrow lanes make service by vehicle difficult and often impossible. The problem of solid waste storage and collection are most acute in such areas, means some older city or inner areas where there are very narrow lanes. Next factor is financial and foreign exchange constraints. Solid waste management accounts for sizable proportion of the budget of municipal corporation. This is allocated for capital resources which go towards the purchase of equipments, vehicles and fuel and labor cost. Generally 10% to 40% of the revenue of municipalities are located to solid waste management. In regions where wages rates are low, the aim is to optimize vehicle productivity. Next factor affecting solid waste management system is cultural constraints. In some regions, long-standing traditions preclude the intrusion of waste collection on the household and therefore they influence the collection system. While in others, where the tradition of caste persists, recruiters of the labor force of street cleaning and handling of waste must be drawn from certain sections of population. Waste management should be therefore very sensitive to such local patterns of living and consider these factors in planning, designing and operation. Our next factor affecting is management and technical resources. The solid waste management to be successful, it requires a wide spectrum of workforce in keeping with the demands of the system. Next is the global municipal solid waste. In global urbanization and increase in income, it results in significant rise in municipal solid waste. In past 10 years, it is from 0.64 kg per person per day to 1.2 kg per person per day. And in 2025, it will be 1.45 kg per person, 42 kg per person per day. In LAC, total amount of waste generated per year in this region is 160 million ton, with the average per capita value of 1.1 kg per capita per day. These were the data of global municipal solid waste. Next is the characteristics of solid waste. The first is physical characteristics, in which the first physical characteristics is density. Density is expressed as mass per unit volume, that is kg per meter cube. This parameter is required for designing a solid waste management program in which a reduction in volume by 75% is achieved through normal compaction equipment, so that an initial density of 100 kg per meter cube may be readily increased to 400 kg per meter cube. Some changes in the density occurs as waste moves from sources to disposal site as a result of handling, wetting, scavenging and drying by the weather and vibration during transport. Density is critical in the design of sanitary landfill as well as for storage, collection and transport of the waste. Next is moisture content. The values greater than 40% are not common. Moisture increases the weight of the solid waste and therefore the cost of collection and transport also increases. The waste should be insulated from rain or other water source. The moisture content is critical in the economic feasibility of waste treatment by incineration. During incineration, energy must be supplied for evaporation of water and raising the temperature of vapor. So to determine the moisture content, there is a formula. Moisture content will be determined in percentage, which is equals to wet weight minus dry weight divided by wet weight into 100. Next physical characteristics is size. The measurement of size distribution of particle in waste stream is important because of its significance in the design of mechanical separator and shredders, because we need to design some mechanical separator and shredders. So for this purpose size distribution of particle is very much important. Next is permeability. The hydraulic conductivity of compacted waste is an important physical property because it governs the movement of liquids and gases in the landfill. It depends on pore size distribution, surface area, and porosity. Next characteristics is chemical characteristics. The information of chemical characteristics is important in evaluating the processing and recovery options. Typically, waste is considered as combination of combustible and non-combustible components. If solid waste is to be used as a fuel or for any other use, we should know its chemical components. So the first chemical characteristics is lipids. These are included in the class of fats, oils and grease. The principal source of lipids in the garbage are cooking oil and fats. Lipids have high heat values about 38,000 kilojoules per kilograms, which makes the waste very high lipid content suitable for energy recovery. Since lipids become liquid at temperature slightly above the ambient and they add to the liquid content during waste decomposition. Lipids are biodegradable but they have low suitability in water and hence the rate of biodegradation is very slow. Next is carbohydrates. These are primarily originated from the food source rich in starch and cellulose. These readily biodegrade into carbon dioxide, water, and methane. The decomposition of carbohydrate attracts the flies and rats and hence should not be left exposed for longer duration. Next chemical characteristics is proteins. These are the compounds containing carbon, hydrogen, nitrogen, and oxygen, and organic acid with amino groups. They are primarily found in food and garden waste. But their partial decomposition results in the production of amines which impart unpleasant odor. Next chemical characteristics is natural fibers. These are the natural products which contain cellulose or lignins. They are relatively resistant to biodegradation. These are found in paper products, food and yard waste. Paper is almost 100% cellulose, cotton is over 95%, and wood products are about 40 to 50% cellulose. These are highly combustible products more suitable for incineration. The calorific value of oven dried paper products are in the range of 12,000 to 18,000 kilojoule per kilogram. Next chemical characteristics is synthetic organic material. In recent years, plastics have become the significant components of solid waste. So accounting for 1 to 10%, they are highly resistant to the biodegradations and hence their presence in the waste is objectionable. Nowadays, much attention is given to reduce this component at disposal sites. Plastics have a high heating value, about 32,000 kilojoule per kilogram, which makes them very suitable for incineration. However, among the plastics, polyvinyl chloride, that is PVC, when it is burnt, it produces dioxin and acid gas. Next step is on-site storage and processing. So on-site storage is done by using hauled and stationary containers. The design of an efficient waste collection system requires a careful consideration of the type, size, and location of containers at the point of generation of storage for waste. While single family households generally use small containers or residential units, commercial units, institutional units, and industrial units require very large containers. Smaller containers are usually handled manually, whereas the larger, heavier ones require mechanical handling. So the containers may fall under two categories. First is stationary container and second is hauled containers. Stationary containers are used to be transferred to collection vehicles and at the site of storage. And the hauled containers are used for contents to be directly transferred to the processing plant or transportation station or disposal site. So the desirable characteristics of a well-designed container are low cost, size, weight, shape, resistant to corrosion, water tightness, strength and durability. So these are some characteristics for well-designed container. For example, a container for manual handling by one person should not weigh more than 20 kg. The containers that weigh more than 20 kg when full, they require two or more crew members to manually load or unload the waste. And this result in low collection efficiency. The container should not have rough or sharp edges and they can be handled easily and a wheel to facilitate mobility. There should be a wheel at the bottom of the container to facilitate easy mobility. They should be covered to prevent rainwater from entering because it increases the weight and the rate of decomposition of organic materials. The container body must be strong enough to resist and discharge stray animals and scavengers from driving as well as withstand rough handling by the collection crew and mechanical loading equipment. The container should be provided with a lifting bar and compatible with the hosting mechanism of the vehicle. The material of the container should be light, recyclable, easy molded, and the surface must be smooth, resistant to corrosion. On the other hand, wooden containers, example of bamboo or wooden basket, which readily absorb and retain moisture, and their surface are generally rough, irregular, and difficult to clean. Next is waste processing techniques. The techniques which are used for waste processing are improving efficiency, then recovering material for reuse, and last technique is recovering conversion product and energy. So the processing of waste helps in achieving the best possible benefit for every functional element of the solid waste management system. And therefore, it requires proper selection of techniques and equipment for every element. The waste that are considered suitable for further use, they need to be paid special attention in terms of processing, because we could derive maximum economical value from them. So the first technique is improving efficiency of solid waste management system. Various processing techniques are available to improve the efficiency of solid waste management system. For example, before waste papers are reused, they are usually reduced for transporting and storage volume requirement. In some cases, wastes are reduced to the haul cost at disposal site, where solid waste are compacted to use the available land effectively. If solid wastes are to be transported hydraulically or pneumatically, some form of shredding is also required. Shredding is also used to improve the efficiency of disposal site. So by using some techniques such as shredding, the efficiency can be improved of sewage solid waste management system. Next technique is recovering material for reuse. Usually materials having a market when present in waste in sufficient quantity to justify their separation are most useful to recovery and recycling. Materials that can be recovered from solid waste, including paper, cardboard, plastic, glass, some metals, aluminium, and other residual metals, these can be reused after the treatment. Next technique is recovering conversion products and energy. So, combustible organic materials can be converted to intermediate products and they can be used as a usable energy. These can be done either through incineration, pyrolysis, composting, or biodigestion. Initially, the combustible organic matter is separated from the other solid waste components. Once they are separated, further processing like shredding and drying is necessary before the waste material can be used for power generation. Next is the waste evaluation options in India. The problem of municipal solid waste management has acquired the dimensions in India, especially over the last decade. Before which waste management was hardly considered an issue of concern as a waste, because the waste could be easily disposed of in the environment in the safe manner. The physical and chemical characteristics of Indian city refuse, and they show that about 80% of the waste is compostable and ideal for biogas generation due to adequate nutrients. The moisture content of 50 to 55% and the carbon to nitrogen ratio of 25 or 40 ratio 1. So the waste evaluation option in India are discussed below. That is, the first is waste quantum. In waste quantum, the per capita waste generation rate is about 500 gram per day. These, along with increased population, has contributed to higher total waste generation quantum. Second option is waste composition. Studies reveal that the percentage of organic matter has remained almost static at 41% in the past 3 decades. But the recyclables have increased from 9.56% to 17.18%. The garbage in Indian cities is estimated, and it contains about 45 to 75% biodegradable waste and 50 to 55% moisture, then 35 to 45% fruits, vegetables, and food biomass, then 8 to 15% of non organic materials like plastic, metals, glass, stone, etc. The refuse from Indian cities also contains high organic and low combustible matter. If the studies carried out in 6 cities are of many indication. The next option is waste disposal method. Waste disposal is the final stage of the waste management cycle. About 90% of the municipal waste collected in India is dumped in low-lying areas outside the city-town limits, which have no provision of leachate collections and treatment and landfill gas collection and use. Our next option is recycling. This involves collection and recyclables from various sources, which ultimately reach recycling units. It is estimated that about 40 to 80% of plastic waste gets recycled in India as compared to 10 to 15% in developed nations of the world. However, due to lack of suitable government policies, incentives, subsidies, regulations, standards, etc., they are related to recycling. This industry is still far behind its Western counterparts in the terms of technology and quality of manufactured goods. Our next option ways of waste evaluation in India is health impacts. Due to the absence of standards and norms for handling municipal waste, municipal workers suffers occupational health hazards of waste handling. At the dump site in the city of Mumbai, for example, 95 workers were examined and it was found that about 80% of them had eye problem, 73% have respiratory ailments, 51% have gastrointestinal ailments, and 27% have skin lesions or skin infections. Also, municipal workers and rag pickers who operate informally for long hours, they also suffer from similar occupational health diseases, which are ranging from respiratory illness, infections, then hepatitis, leading to tetanus, headache, nausea, etc. Studies among the 180 rag pickers at open dump of Kolkata city, they reveal that an average quarterly incidence of diarrhea was 85%, fever was 72%, cough and cold was about 63%. The next option of waste evaluation in India is environmental impacts. In addition to occupational health, injury issues and environmental health also need to be mentioned in the context of waste management. Contaminated leachate and surface runoff from land disposal facilities affects ground and surface water quality. So the volatile organic compounds and dioxins in air emissions are attributed to increasing hazard resilience. Drain clogging due to uncollected waste, it leads to stagnant water and subsequent mosquito vectors breeding is a few of the environmental health issues. And these affect the waste workers as well as the public. Next is vehicle storage method. In this first is collection vehicle. Almost all collections are based on collector and collection crew, which move through the collection service area with a vehicle of collecting the waste material. The collection vehicle selected must be appropriate to the terrain, type, and density of waste generation points. It also depends upon strength and capability of the crew that will work with it. The collection vehicle may be small and simple. Example, it may be two-wheeled cart pulled by an individual or large, complex and energy intensive can be used. The most commonly used collection vehicle is a dump truck fitted with a hydraulic lifting mechanism. So collection vehicles are divided into two types, that is small scale collection and muscle powered vehicles. These are common vehicles which are used for waste collection in many countries and are generally used in rural hilly areas. You can see in the figure, in this figure, these are the small scale collection and muscle powered vehicle. These can be small rickshaw, cart or wagon pulled by people or animal and are less expensive. They are easier to build and maintain compared to other vehicles. They are suitable for densely polluted areas with narrow lanes where there is relatively low volume of waste generation. There are some drawbacks of this collection vehicle includes limited travel range of the vehicle and weather exposure that affect humans and animals. Second are non-compactor trucks. Non-compactor trucks are efficient and low cost effective in small cities and in some areas where waste tend to be very dense and have little potential for compaction. When these trucks are used for waste collection, they need a dumping system to easily discharge the waste. It is generally required to cover the trucks in order to prevent residue flying off. The trucks with capacities of 10 to 12 meter cube are effective. If the distance between the disposal site and collection area is less than 15 km, then the trucks with capacity about 10 to 12 meter cubes are effective. If the distance is longer, a potential transfer station closer than 10 km from the collection area is required. The non-compact trucks are generally used when labor cost is very high. Next type is compactor truck. The compaction vehicles are more common these days. Generally, they are having capacities of 12 to 15 meter cube. Although the capacity of a compaction vehicle is similar to that of dump truck, and the weight of solid waste collected per trip is 2 to 2.5 times larger since the waste are hydraulically compacted. The waste in these trucks are compacted. Into the vehicle, it works poorly when waste stream is very dense, wet or collected materials are gritty or abrasive, or when the roads are dusty. The advantage of these compactor trucks are The containers are uniform, large, and covered. The waste is set out in the container so that the crew can pick up them quickly. Health risk to the collectors and odor on the street are minimized. The waste is relatively inaccessible to the waste pickers. Next is the collection and transfer. So the collection components are first collection point. These affect such collection system components as the crew size and storage, which ultimately control the cost of collection. Note that the collection point depend on locality and may be residential, commercial or industrial. Next is collection frequency. The climatic conditions and requirements of the locality as well as containers and cost determine the collection frequency. In hot and humid climates, for example, solid waste must be collected at least twice a week as a decomposing solid waste produces bad odor and leachate. And as residential waste usually contain food waste and other rotting material, frequent collection is desirable for health and aesthetic reasons. Other than climate, the quality of solid waste containers on site also determines the collection frequency. Collection efficiency largely depends on the demography of the area, such as income group, community, etc., where the collection takes place. Next is storage containers. The proper container selection can save energy, collection energy, and increase the speed of collection and reduce crew size. Most importantly, containers should be functional for the amount and the type of materials and the collection vehicles which are used. Containers should also be durable, easy to handle, and economical, as well as they should be resistant to corrosion, weather, and animals. In residential areas where refuse is collected manually, standardized metals or plastic containers are typically required for waste storage. When mechanized collection systems are used, containers are specifically designed to fit the truck mounted loading mechanism efficiency. That is, the container should help maximize the overall collection efficiency. The containers must be easily manageable both for residents and collection crew compatibility. The container should be securely covered and stored, and the municipal ownership must guarantee compatibility with collection equipments. Next is collection crew. The optimum crew size for the community depends on labor and equipment cost, collection method, and route characterization. The size of collection crew also depend on the size and type of collection vehicle used. For example, increase in waste generation rate and quantity of waste collected per stop due to less frequent collection result in bigger crew size. It is possible to adjust the ratio of collectors to collection vehicle such that the crew idle time is minimized. However, it is not easy to implement this measure as it may result in an overlap in the crew collection. Next is collection route. The collection program must consider the route that is efficient for collection. The efficient routing for collection of solid waste vehicles helps decrease cost of reducing the labor that are expanded for collection. Proper planning of collection route also helps conserve energy and minimize working hours and vehicle fuel consumption. It is important to develop detailed route configuration and collection schedules for the selected collection system. The size of each route should depend on the amount of waste collected per stop, the distance between stops, loading time, and traffic conditions. Some barriers such as railroad, embankments, river, and roads with heavy traffic can be considered to divide route territories. And the last process of collection and transfer is transfer station. A transfer station is an intermediate station between final disposal option and collection point to increase the efficiency of the system. If the disposal site is far from the collection area, it is justified to have a transfer station where smaller collection vehicles transfer their load to larger vehicles. In some instances, the transfer station serves as a pre-processing point where waste are dewatered, scooped, and compressed. A centralized sorting and recovery of recyclable material are also carried out at transfer station. The unit cost of hauling solid waste from a collection area to the transfer station and then to a disposal site decreases as the size of collection vehicle increases. So this was all about the solid waste management system, in which we had studied about the characteristics, that is physical, chemical, then the generation of solid waste, then how we collect the solid waste, what are the processes, then the transportation of solid waste, then the techniques which are used for solid waste management, then their disposal and treatment. So we had completed this syllabus, or we had covered all the points of municipal solid waste management system. So thank you all for joining us.